Good morning friends. In this video lecture I will explain about the signal and system. What is the importance of the subject in our day-to-day life and what is the importance of the subject from the gate point of view. So as you know, we have different types of information in our day-to-day life, like speech information, picture information, the electrical circuits. You have the voltage information, current information. These information depends upon the independent variable. For example, your speech information depends upon your acoustic pressure or vocal tone. Your picture information depends upon your spatial variable, and your current and voltage depends upon your time, right? So we have some information, and this information depends upon independent variable. So this information is known as your signal. So your signal is basically a function which depends upon independent variable and which contains some information. So we have many different types of signal in our day-to-day life. Now something about the system. System is something which takes input and gives the output signal. For example, if you have an automobile car, this automobile car has some accelerators, some pedal. If you are pressurizing this pedal, then your automobile car will accelerate. So input is your pressurizing pedal and output is your acceleration of the car. So we have many applications of this signal and system in our day-to-day life. Now what is the importance of this subject from the gate point of view? As you know, the gate contains 100 marks. The total number of marks in the gate exam is 100 marks. Out of 100 marks, the weightage of these subjects, particular subjects, is 10 to 12 marks. Right? So from gate point of view, this subject is very important. Another importance of this subject is that in this syllabus of this subject, we contain Laplace transform, Z transform, Fourier transform, and these transformations are the tool through which we can analyze the signal in the time domain as well as in the frequency domain. So, and we need these transformation in the control system and circuit analysis also. So from this point also, this importance of this subject is very high. Now, why the gate exam is having a very importance? So the BTech students or engineering students who want to go for higher studies in good institutes, he have to have some good gate score. Another importance of this gate exam is that those students who want to get some good job in the public sector undertaking, they also should have some good gate score. That's why the importance of the gate exam is very high. Right. Now I am coming to the theory part of the topic of the signal system. In this video lecture I will explain two topics. First one is the basic introduction, basic signals, some basic signals, introduction of some basic signal, and second point is the some basic operation on signal. I will cover these two topics in this video lecture. So first I will coming to the point, some basic signals. Basically there are four types of signal. One is the unit step signal. You note down, unit step signal. Second is your unit impulse signal. Third one is your unit ramp signal. Fourth one is your parabolic signal. So signal, we know that signal is a function of independent variable which depends. Signal is a function of independent variable which contains some information, right? So first one is your unit step signal. Note down, unit step signal. The definition of the unit step signal is ut is equals to 1 when t is greater than or equal to 0, 0 when t less than 0, and the pictorial diagram of this unit step is equals to this one. So ut is equals to 1 when t greater than or equals to 1, when t greater than or equals to 0, and its value is 0 when t less than 0. Second is your unit impulse signal. So the definition of the unit impulse signal is delta t is equals to 1 when t equals to 0, when t is not equals to 0, then value of the delta t is equals to 0. The notation of the unit impulse signal is delta t. So value of the delta t is equals to 1 when t is equals to 0, and which value is 0 when t is not equals to 0, and the integration of this delta t over complete time duration is 1. So this is delta t, or this is delta by 2 minus this is the delta t signal. Area under this curve, area under the delta t is 1. Okay, so this is the definition of the unit impulse signal. Now third one, you can say unit ramp signal. What is unit ramp signal? The notation of the unit ramp signal is equals to RT, and RT is equals to T. RT is equals to T UT, and pictorial diagram of RT is equals to this one. So this is your unit ramp signal. Unit ramp signal is equals to T into T UT. Right. So this is the pictorial diagram of the ramp signal. Fourth one is the parabolic signal. So if x is your parabolic signal, then value is the t square by 2 UT. This is the pictorial diagram of the parabolic signal. So these are the basic signals. First one was the unit impulse, unit step signal. Second was the unit impulse signal. Third is the unit ramp signal, and fourth one is the parabolic signal. Right. Now I am coming to the topic, the operation on the signal. Different operation on the signal. Operation on the signal. So first operation is the shifting operation. Shifting is possible in the time as well it is possible in the amplitude axis. So shifting in the time axis as well as in the shifting is possible also in the time axis. Second point is scaling. Scaling is possible also in the time as well as in the amplitude. And third one is the reversal, time reversal. Time reversal is a special case of the time scaling, where scaling factor is equals to -1. We will see later that what is the scaling factor, and how the time scaling is related to the time reversal, right? So first point, time scaling. First point, note down, time scaling, right? Time shifting. First one is the time shifting. So time shifting also may be the two types. One is the delay in time, second one is the advance in time. Delay in time is known as right shifting. If you are shifting the signal in the right side, then it is known as the delay of the signal, right shifting. And second one is the advance of the signal. This is known as the left shifting. This is known as the left shifting. If you are shifting the signal in the left side, then it is known as the left shifting. Let's say I will explain with the help of example. Let's say you have a signal xt, which is equals to ut. So you know what is the ut? Ut is equals to 1 when t greater than equals to 0, and its value is 0 when t less than 0, right? Now you have delayed the signal by the value of t naught. So what will be the yt? Yt will be equals to u of t minus t naught. So this will be the yt will be equals to 1 when t minus t naught is greater than equals to 0. This implies t should be greater than equals to t naught. Its value is 0 when t minus t naught is less than 0. This implies t is less than t naught, right? So yt is equals to 1 when t is greater than equals to t naught. And so what will be the pictorial diagram of this yt? The pictorial diagram of this yt will be the graphical. This is your t naught, this is your t. So from this graph you can say you have delayed your signal xt, which was starting from 0. Now your yt is starting from t0. So this is the delayed version of the signal xt. Now second, or this was the delay or the right shifting. Now second, again you take xt equals to ut and yt is equals to this time x of t plus t0. So what will be the yt? Yt will be the u of t plus t0, and value of yt will be equals to 1 when t plus t0 is greater than equals to 0. This means t should be greater than equals to minus t0, and its value is 0 when t plus t0 is less than 0. This means t is less than minus t0, right? And the pictorial diagram of this yt will be the this one. It will start from minus t0. So yt is equals to 1 when t is greater than equals to minus t0, and its value is 0 when its t is less than minus t0. So this is the case of the advance of the signal. So this was the case in the time shifting case, which is the advance of the signal. Now second point, amplitude shifting. Amplitude shifting is of two types. One is the upward shifting, another one is the downward shifting. We will see this amplitude shifting with the help of an example, how the signal is shifted to the upside and how the signal is shifted to the downside. Let's say you have a signal xt equals to ut, and you are familiar with the signal ut, which is equals to 1 when t is greater than equals to 0, and its value is 0 when t less than 0, right? Now you have a signal yt equals to xt plus k. Now case first, when k is greater than 0, this is the case of the upward shifting. Your signal will be shifted by the magnitude k with in the upside. So this is the case of the upward shifting. How? Yt is equals to the ut plus k when, and your pictorial diagram to the ut was 0 when t less than 0, but this time your k is existing, so the value will be the k. Now ut was 1 when t is greater than equals to 0. When ut was 1 when t is greater than equals to 0, but now yt will be the 1 plus k when t is greater than equals to 0. So this is your yt. So your signal is shifted by the magnitude k. So this is the case of the upward shifting. Now second possibility of the signal is downward shifting. How the signal is downward shifting? Now second case, case number second, when k is less than 0, then this is the case of the downward shifting. Why downward shifting? Because this time your signal will be shifted to the downside by the magnitude k. So your yt will be equals to ut plus k, and k is less than 0. That's why your ut was 0 when t less than 0, but this time your yt will be k, and k is less than 0. That's why its value will be the downside. Now ut was 1 when t greater than equals to 0. But this time your yt will be 1 plus k, and k is less than 0, so value will be the 1 plus k, which is less than 1. So your yt will be the 1 plus k, because your k is less than 0. That's why 1 plus k will be less than 1, right? So this is the case of the amplitude shifting of the signal. Now second operation. First operation we have seen the shifting in the time axis as well as shifting in the amplitude axis. Second case is the scaling. Scaling is also possible in the time axis as well as scaling is possible in the amplitude scaling. So first is the time scaling. Time scaling is also two types. One is the compression of the signal, and another one is the expansion of the signal. Time scaling is the two types. One is the compression of the signal, another one is the expansion of the signal. First, let's say first case, you have a signal xt is equals to ut, and we are familiar with the ut. Now yt is equals to x of at. So we have scaled the time axis with value a, where a is any constant. Now case first, when a is greater than 1, then this is the case of the compression. Why the compression? I am explaining with the help of the graph. Let's say, what is your xt? Xt is equals to sorry, cut कर देंगे इसको. Your xt is equals to ut minus 1, right? So what is your xt? Your xt is equals to ut minus 1. So what is your xt? Your xt is equals to 1 from 0 to 1, because ut is equals to 1 when t greater than 0, and ut minus 1, which is the delayed version of the ut, its value is 1 from when t is greater than 1. So ut minus 1 is equals to 1 from 0 to 1. Now what will be the yt? Yt is equals to x of 80. That's why yt is equals to x of 80. So that's why yt is equals to 1 when 80 is less than equals to 1 and 80 is greater than 0. This means t is less than 1 by a and t is greater than 0. So what will be the yt? What will be the yt? Your yt will be the 1 when t is less than equals to 1 by a. Your a is greater than 1, that's why 1 by a will be less than 1. So this is your yt. So your signal xt was present from 0 to 1, but your signal is yt is present from 0 to 1 by a, and 1 by a is less than 1. That's why you can say the signal has been compressed. So this is the case of the compression of the signal, right? Similarly, if your case second a is less than 1, this is the case of the expansion of the signal. This time your yt will be equals to 1 when at is less than equals to 1 and greater than equals to 0 else other. And this time your t will be less than equals to 1 by a and greater than equals to 0. But here a is less than 1, that's why 1 by a is greater than 1. So what will be the yt? Yt will be equals to 1 from 0 to 1 by a, and here your 1 by a will be greater than 1 because a is less than 1. That's why you can say you have expanded the signal xt, because your signal xt was present from 0 to 1 only. Now your yt is present from 0 to 1 by a, which is where 1 by a is greater than 1. That's why you can say you have expanded the signal. So this is the case of the expansion of the signal. So we have seen the time scaling of the signal. Now we will see amplitude scaling of the signal. So amplitude scaling of the signal has the two types. Amplitude scaling of the signal has the two types. One is the amplification of the signal. Another one is the attenuation of the signal. So let's say xt is equals to, again you can take ut, no problem. So and yt is equals to aut. This time you have multiplied by the constant or scalar aut. Now case first. When a is greater than 1, this is the case of the amplification of the signal. How amplification? Let's say, what is xt? Xt is equals to 1 when t greater than equals to 0. Its value is 0 when t less than 0. Now what is the yt? Yt will be equals to a, because a multiplied by 1 is equals to a when t is greater than equals to 0. And its value is 0 when t less than 0. So your this time and a is greater than 1, then that's why you can say the signal is amplified by the magnitude a. Similarly, second case is also possible. This is the case of the amplification. Now second case, when a is less than 1, this is the case of the attenuation of the signal. This time your yt will be yt equals to, or you can say yt is equals to a when t is greater than equals to 0. But this time your a is less than 1, that's why this will be the attenuated by the signal by the a times, right? So this is the case of the attenuation of the signal. So we have seen the we have seen the scaling in the time axis as well as scaling in the amplitude axis. So scaling in the time axis is the two types. One is the compression of the signal. Another one is the expansion of the signal. Similarly, amplitude scaling is also two types. One is the amplification of the signal, another one is the attenuation of the signal. So if you have a scaling factor which is greater than 1, then you can say it is amplified of the signal. Another one, if you have the your scaling factor is less than 1 then you will say it's a attenuation of the signal. You can take any other example also. Let's say xt is equals to sin t, and yt is equals to a of sin t. Similarly, this time you will also can visualize, if a is greater than 1, then your signal will be the amplified. Similarly, if a is less than 1, then this time your signal will be the attenuated signal. So this is the attenuated signal, dotted line which I have shown in the graph. This is the attenuated of the signal, and this is the amplified of the signal. Right? So I think it is clear. Amplification of the signal as well as the attenuation of the signal. Third case, time reversal. Time reversal is a special case of the time scaling. Time reversal is a special case of the time scaling, in which your scaling factor is equals to -1. Let's say xt is equals to, in which your scaling factor is equals to -1. Let's say xt is equals to u of t, and yt is equals to scaling factor. So x of, let's say this is the scale version of the signal xt. By scaling factor is a, but a is equals to -1. So a is equals to -1, then what is the yt? Yt is equals to x of minus t. Now we will see what is the graph of x of minus t. So as we are familiar